A solution contains chromium 3 plus ion and magnesium 2 plus ion. The addition of 1 liter of 1.51 molar sodium fluoride solution causes the complete precipitation of these ions as chromium 3 fluoride and magnesium fluoride. The total mass of the precipitate is 49.6 grams. Find the mass of chromium 3 plus ion in the original solution. Okay, so this is basically knowing how to first figure out what a precipitation reaction even means. So you have a solution that has these two ions in them, chromium and magnesium, and then sodium fluoride was added, and it formed two precipitates that actually has sodium fluoride in it. So basically, if you were to write the precipitation reactions of these two, it would look something like this, right? Chromium 3 plus fluoride makes chromium 3 fluoride. Since there's 3 fluorides, we have to balance. And the magnesium would look like this. And we want to know how much mass of this was in the original solution. We're given how much was added to create those ions and compounds, and there's fluoride in both of them. So it's going to have to be creating some kind of equation right off the bat. Let's first figure out how much moles of fluoride we have. So we know that have sodium fluoride, and if you split that up, that's 1 mole of sodium ion plus 1 mole of fluoride ion. So 1 liter of sodium fluoride times the molarity to get moles (1 mole of fluoride, because that's what we care about here, will leave us with 1.51 moles of fluoride ion. Okay, so now we have the amount of fluoride ion that's needed to precipitate. So we know 1.15 moles of fluoride ion is needed to precipitate chromium 3 fluoride and magnesium fluoride. The way that we were able to figure that out is because that was the amount used. So 1 liter of 1.51 molar sodium fluoride was used, and then those two precipitates formed. Since fluoride is in both of them, finding just the moles tells us that that many moles was needed to make both of these precipitates, both of these solids. Okay, so since it's in both of them, right off the bat, I think I'm just going to make an equation right now. I'm going to assume that chromium 3 plus is X and magnesium 2 plus is Y. And I know that X plus Y will be the amount of moles of fluorine ion. Well, I have 3 moles of fluorine in chromium 3 fluoride and 2 moles of fluorine in magnesium fluoride. And so I'm going to add that into my equation, giving me 3x plus 2y is therefore equal to 1.51 moles. Okay, then I'm going to create my mass equation, step 3. I know that the total mass is 49.6. So chromium and magnesium made 49.6 grams, which is also saying X plus Y is equal to 49.6 grams. To find grams, we can use molar mass. So we can plug into that equation the molar mass of both, which then gives us 109.00 x plus 62.31 y is equal to 49.6. So now we have two equations. This is my equation 1, and this is my equation 2. And I want to isolate for chromium. So the next step would then be to solve for one variable using system of equations. So what that means is I placed my two equations on top of one another. And then solve for one variable by making one of them equal each other. So I took this, multiplied the top by 109.0, and multiplied the bottom by 3, which then gives me 327x plus 218y is equal to 1.51 times 109 is 164.59, and then the bottom was 327x plus 186.93y, which equals 148.8. And then you isolate for x, which cancels that out, and you're left with 31.07y is equal to 164.59 minus 148.8 is 15.79. Then you isolate for your y, which is 0.508, and that represents the moles from the original equation. And then since we want x because we want chromium, then we go back and solve for x, since x is for chromium, and that's what we care about. You go back to the equation, 3x plus 2 times the y of 0.508 is equal to 1.51, which gives us 2 times 0.508. And then 1.51 minus that, and then that divided by 3 is 0.161. And then convert to grams. So 0.161 moles Cr3 plus times the molar mass, 52.01 grams per mole, is equal to 8.38 grams, since we want two significant figures. So that is the amount of the ion in the solution. So the question just came back to being about two unknowns. We know that we have these two ions that are in solution, and then in this solution, all of a sudden, we added 1 liter of 1.51 molar sodium fluoride. This then caused these two precipitates to completely form. And the total mass of the precipitate was 49.6. So that means the precipitate in total that has both of these has this mass. Knowing that you can split up the equations and fluorine is in both of them, we found the amount of fluorine ion in the solution and use that to isolate for the moles of these two ions. Then also knowing that this mass of chromium 3 fluoride and magnesium fluoride made 49.6, we created another equation using the molar mass of the ions. Then just using algebraic two equations, two unknowns, we solved for one variable by itself, plugged it back in. It doesn't matter which variable you solve for. I solved for y because it was a little easier. Then, actually, no, it wasn't necessarily easier just because I wanted to. And then knowing that you have to go back to x because I assigned that chromium was x, then back to grams using the molar mass.